nothing else. Okay, I understand. But give me 5 minutes. Okay, I will be back in 5 minutes. Okay.
Okay, sir.
Okay. Okay. So let us start the chapter hydrocarbons. Okay. Let us start the chapter hydrocarbons. All of you have your notebook and pens, yes or no?
Yes.
Right? Yeah.
Yes, sir.
Okay. Fine. So in this chapter, that is hydrocarbon. hydrocarbons. So we can say that we will be learning about alkanes. Okay, we'll be learning about alkenes. We'll be learning about alkynes. We also will be learning about benzene and its derivatives. Okay, benzene and its derivatives, or we can say aromatic compounds. Then we will be learning about aromatics. Okay, the 4 parts. So alkane, alkene, alkyne, and aromatic. So alkene, these are alkanes. This will be saturated. Only single bond. Only single carbon-carbon bond. Alkenes will have unsaturated. They will have double bond. At least one double bond will be present. In alkynes, this will be also unsaturated. And there will be at least one triple bond. And aromatic will have benzene and its derivatives. Benzene and its derivatives. Okay, so some groups will be attached here. Okay. Some groups will be attached here. So these are the 4 classes of compounds that we are going to study. What are we going to study? We will be studying the general structure. General structure, first of all, of alkenes, alkynes, and aromatics, all of them. Then in alkene, alkene, and alkynes, we will be studying about. So for these 3, there will be a general pattern that you can see. For all of these 3, we will be studying about structure. Then we will be studying about its preparation. Okay, we'll be studying about structure. We will be studying about its preparation. We will also be studying about some of its isomerism. In structure only, we will be studying about isomerism. Some parts of that isomerism we have already done in the previous chapter. Okay, we have done in previous chapter. Then after that, we will be learning about the physical properties. Physical properties, and in physical properties, mainly we will be learning about the melting point and boiling point. And at last, we'll be learning about the chemical properties. In chemical properties, we'll be learning about reactions. Okay, we'll be learning about reactions. So these are the 4 main things that we should be knowing. So at the end of the chapter, you should know these. What is the structure, the preparation, the melting point and boiling point trends, and the chemical reactivity of alkene, alkenes, and alkanes. So for aromatics, we will we can't. So structure, we can say structure, we can learn the preparation, we can learn about the chemical properties. Isomerism, not so much, right? Isomerism, not so much. Similar kind of things what we will be studying about here. Benzene also. We can't also study melting point and boiling point in very much detail, because benzene is just benzene. And in alkenes, we have a different class number of carbon atoms. It differs. And that is why we can talk about the trend of melting and boiling points. Fine. So let us start with alkenes first of all. And the first topic that we are going to study will be alkenes. So write the topic. Write the topic alkenes. Alkenes. Number 1. These are what? Saturated hydrocarbons. These are saturated hydrocarbons that contain only carbon-carbon single bonds. So the carbon-carbon bonds will be all single bond. These are also known as paraffins. These are also known as paraffins. Okay, that means paraffins means para means little. Affins is derived from affinity. Okay, that means alkenes, they are not very much reactive. They don't have affinity towards any other element or any other atom molecule. Okay, so they don't react very much. That is why they are also known as paraffins, derived from. अच्छा ये para नहीं है, this will be param means little, not para. Param means little, affins is derived from affinity. Means that alkanes have low reactivity. Alkanes have low reactivity. We can say there are two classes of alkenes. Number one is open chain alkenes, which have the general formula CN H2N plus 2, right? CN H2N plus 2, and there is cyclic alkanes, which have the general formula CN HN. CN H2N, na? Yeah, CN H2N. CNH2N. Examples of cyclo alkanes will be cyclic alkanes will be CH2, CH2, CH2. What is this? This is cyclopropane. Cyclopropane. So what will be this compound, guys? Tell me. And you all write the names for these compounds now. Also write the name for this. Yes. Tell me what is the name?
Cyclobutane.
Cyclo. What will be this?
Cyclobutane.
Butane. This will be cyclo.
Pentane.
Pentane. This will be cyclo.
Hexane.
No, very good. Cyclohexane. Now, write the structure of. Achha, before structure, let me revise some parts of the nomenclature. Okay, some parts of the nomenclature. So write this name. Write this question. Write the IUPAC nomenclature of the following. So whenever you have this type of question, whenever you have this type of question, when you have the condensed formula, so you will write all the non-bracket ones first of all. If you have alkene in which you have been given a bracket alkenes, then you will write all the non-brackets one first. So you will write carbon, CH2, carbon. Okay, so we have written this much. Now I can see this carbon, it is attached to CS3 and there are 3 CS3s attached here. Similarly, this CS3 also has 3 more CS3s. Okay, so this is the way how you are going to write the structure first of all, then only you can write the IUPAC nomenclature. For the second question, you have only one carbon, so you'll write one carbon like this, and you see that it is attached with 2 C2H5. There will be 2 molecules of C2H5 means what? CH2, CH3. This is also CH2, CH3, and there is 2 CH3 molecules. Okay, so write these two first of all. And try to write the name. The main thing here is that a functional group, unsaturation, all things are fine. You have to first of all identify the parent and then the substituent. So main thing is to identify the parent. Parent के लिए please remember terminal to terminal, है ना? So those things, if you remember those concepts, very first principle, basic principles, then you can easily see what is the parent here. Tell me what is the parent in the first structure? How many carbons? हाँ guys.
3 carbons.
3 carbon parent में. अरे Matthew.
Oh, no, there's one. Sorry, yeah, there's one.
1 carbon.
Yeah, because
What is?
because
Ah,
CH2
because?
is the parent, right?
Acha. So how do you identify the parent, Matthew? Tell me now.
It's the main chain, I believe.
Main chain.
So,
Okay. You have not done organic chemistry with me, na?
no, sir. No.
दिख रहा है. What about others? Tell me. Heshma, Samaira.
5 carbons.
Okay. So Matthew, आप यहाँ पे note down कीजिएगा. Okay. You listen
All right.
carefully. है ना? Zainab, what about you? How much carbon did you identify as the parent? Yes, Zainab. हाँ बोलिए तू. I could not hear you. Can you please send me chat, Zainab? How many carbons you identified as the parent? Okay, I was going to ask Aisha. Sarah, you have done organic chemistry with me, right?
Yes, sir.
Okay, so you can identify 5 carbons.
Yes, sir.
Okay, fine. Now Zainab and Matthew, you will start. Acha. There is one word which is known as terminal. Okay, terminal carbon. Terminal carbon means the last carbon. The last carbon. So I can identify there are few last carbons here. Okay, so I've been saying that this carbon is last carbon, this carbon is last carbon, this carbon is last carbon, right? So all of these are last carbon. Yes or no? Tell me.
Yes, sir.
All of these are last carbon. So you will always, the parent, it will be from terminal to terminal. That means from last carbon to last carbon if you have an open chain. If you have an open chain, the main chain, the parent chain, it will start from a terminal and it will end at a terminal. Is that fine?
Oh, yes, sir. Okay.
Okay. First thing is that now you can choose at this point of time any of these terminals. Okay. Any of these terminals, because all of them are same only. All of them are same only. So I will start from this carbon atom. Start from this carbon atom. Okay. Now, at this carbon atom, I have 2 different carbon atoms that I can go. I can either go rightwards or I can go downwards towards this CH3 or this CH3. So what do you think? Where are more carbon atoms? Where should I go? Should I go right or should I go left or down? Tell me. Which way? To get more number of carbon atoms. Where are more number of carbon atoms, Matthew?
Right.
Right. है ना? No. So whenever you have a junction, you have to decide. I will go here, then I will go to next carbon, no junction. Then I will go to this carbon. Now I can go at any of these carbon atoms because all of these diversions that I'm having in the road, they lead to only 1 carbon. Now you can see how many? 5, right?
Yes, sir.
है ना? 5. Now where you start the numbering at this, the numbering starts from that terminal which is nearest to the functional group or unsaturation or the substituent. Right now you will just have substituent. So you can see that this carbon atom or this carbon atom. So you can either number it like this 1, 2, 3, 4, 5, or you can number it like this 1, 2, 3, 4, 5. But both of these numbers are fine because in this above one, the first substituent is at second carbon, and in the below one also first substituent is at the second carbon. Okay, so you can take any of these numbers. and अब okay, अब हम यहीं पे आपको अगर आईयूपैक नॉमेनक्लेचर पढ़ाने लगेंगे क्या फायदा होगा, ऑर्गेनिक केमिस्ट्री आपका है ना, आपको आना चाहिए था। खैर, so the parent is नहीं Matthew, if you want to learn organic chemistry you have to give there are 6 hours of lectures, that means 3 lectures, and if you study them you will be very good at nomenclature. Okay, you will not have to worry.
Okay, sir. All right, sir.
So I use a sequence. I start with functional group. Since there is no functional group, it is E. Second is unsaturation. It will be AN because only single bonds are there. The third is the parent. Parent is pent. Then at fourth, I want to write the substituent. I have to write the substituent. I have identified there are 1, 2, 3, and 4 substituents. There are 4 substituents. Okay, 4 substituents, and all of them are methyl. All of them are methyl. So I will write tetramethyl. Tetramethyl. Tetra represents there are 4, and what is there? It is methyl, tetramethyl. Now I have to number them. So I will number that. There are methyls in the second carbon. There are 2 methyls. So 2, 2, and then 2, 3, 4. 4, 4. Now the name will be 2, 2, 2, 2, 4, 4, tetramethyl pentane. Okay. For this, did you guys write the name for this one? Samira, Hishma? Yes or no? The second one, Samira, how many carbons? What happened? 5 carbons here also, right? You start from here, and at this terminal, you will go this side. Okay, so 5 carbon atoms. Now, for this, I can say that these things will be same. We have 5 carbon, that is pentane, and we have the third carbon, so 3, 3 dimethyl pentane. Okay. It is 3, 3, right, Samira, Ishma?
Yes, sir.
Now this we will study how to write the name of this particular molecule, tetra third butyl methane. Done, guys? Write this down, Matthew, Zainab, Sarah.
Done, sir.
Done. Okay. Then we have tetra tert methyl. This is tetra tert butyl. Okay, so this is a common name they have written. Okay, this is not according to the IUPAC nomenclature. Why? So first of all, whenever you have such kind of thing, so you can see that it is methane. So the parent will have only 1 carbon atom. Right? Methane means only 1 carbon atom. And what are they saying? There is tetra tert butyl. So those who have studied organic chemistry with me, they will remember that tert butyl is this particular fragment. Yes or no? 3 and 4 carbons. When it is attached like this, it is tert butyl, because this carbon point of attachment is 3 degree carbon or 3 degree or the tertiary carbon. You remember all of you tert butyl? Yes or no? Tell me.
Yes, sir.
Yes.
Okay, so we have tert. Tetra means there are 4 such arrangements. So you will have 1, 2, 3, 2, 3, Okay. So this is the molecule that we are dealing with. This is the molecule that we are dealing with. And if you want to write, let me write it like with all the carbon atoms and the hydrogen atom, it will be more better for you guys. Carbon, 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 carbon. All of these carbons are attached with CH3, CH3, CH3. Okay. Now try to find the parent chain terminal to terminal. Try to find the parent chain. Let me know if you are done with the parent chain. If you can identify the parent chain. Okay. नहीं मिला किसी को अभी तक.
Sir, it's
You-
10.
How much? 5 carbon?
5,000, sir.
5 carbon, right? Yeah, 5 carbon. So you can start with any of the terminals, right? Because all of them are same only. You start with from here, then you could do this carbon, then you went to this carbon, right? Now you can go to any of the carbon atoms. I'm going here. You can check with any of the carbon atoms because all of these things are same. Hai na? So you have what? 5 carbon atoms. Start numbering from here. 1, 2, 3, 4, and 5. Right? 5 carbon atoms. Now the parent is pent. Now we are looking for substituents, right? Substituent. And substituent, I can see that in second position we have here we have methyl, here we have methyl. In the fourth position also we have methyl, right? So we can write tetramethyl. Tetramethyl. And then here we have, this is what? Tert butyl. This is also tert butyl. So we have di tert butyl. Yes or no? There is ditert butyl, right? And the tetramethyl it is at 2, 2, 4, 4 position, and the ditert butyl it is at 3, and the other one is also at 3. So the name will be, so here we have methyl and here we have butyl. So first of all butyl will come. So 3, 3 di tert butyl, di tert butyl. Then we have 2, 2, 2, 4, 4 tetra methyl pentane. You write this down. Let me know if you're done. Done?
Yes, sir.
Right, next, isomerism in alkane. Isomerism in alkanes. Okay, so right, alkanes show structural isomerism. They will show structural isomerism in which the isomers differ in their chain length or skeletal. Okay, that is alkanes show chain isomerism. Chain isomerism. So in chain isomerism, we have the chain length will differ. The chain length will differ. So if I start with CH4, the smallest alkane from the series, smallest alkane, then I cannot, we have only one carbon atom, there is no other arrangement, right? So CH will not have any chain isomerism. If I go to carbon, and both of them are bonded with 3 hydrogen, then again, here also I can say that there is no other arrangement that I can have for these 2 carbon atoms, because we have only one bond. If we have only one bond, then both of these carbon atoms will be attached to each other, right? Both of these carbons will be attached to each other. Now, if I have 3 CH3, CH2, CH3. Now, in this case also, there are how many we have. Now, if I want to replace, so whenever we have this type of structure also, we cannot write any chain isomerism because we have only 2 bonds and there is only one way, right, to place the 2 bonds like this, nothing else, right? You cannot place it. I mean, okay, fine, you can place it like this: CH3, CH2, and CH3, but it means the same, right? We don't have any new molecule here. It is same propane. Now, if I look at the next alkane in the homologous series, that is butane, we have CH3, CH2, CH2, CH3. Okay. Now you can see we have 3 bonds like this, right? We have 3 bonds like this. So what can happen? 2 bonds can exist like this, and the other one can go in the middle, right? The other bond can go in the middle, and that is why we can make CH3. 2 bonds will go like this: CH2, CH3. So this will become CH, and here I can put one CH3. Okay. So this is the structure for. This is how we are going to write the 2 isomers for butane. Okay. Now you can see that we have changed the length of chain. So this is what? This is butane. And if I want to write the name of this structure, this is how many carbon? 3 carbons in the main chain, and there is one substituent, that is methyl. So this will be 2-methyl propane. Okay, 2-methyl propane. Write this down. Let me know if you're done. So butane has how many isomers? 2 isomers.
Done, sir.
Done, all of you?
Yes, sir.
Yes. Okay. Next is pentane. So if I look at pentane, we have CH3, CH2, 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 and CH3. So if I want to write this in bond type 2, 3, 4, So we have how many bonds? We have 4 bonds, right? So what we can do is we can also write the structure as 1, 2, 3, 4, and I can place one of the bonds here. Okay, one of the bonds here. So this will be CH3, CH2, CH2, then CH2. So we have got 1, 2, 3, 4. I want to add a CH3 molecule here. Okay, one bond here. So I have to make it CH because carbon can only have 4 bonds and CH3. Like this, you can make one. Like this, you can make one isomer for pentane. Another isomer can be made. See, the basic part is that you will try to keep making different isomer until you have the chain length till propane, है ना? So propane से नीचे chain length मत लेके जाइएगा, but you should have at least till propane, and you will try to make it like this. So we have here how many? 3. We can also reduce now the bond length to 2, and what we can do, we can place one of the carbon atoms, one bond here like this and one bond here like this. So we will get carbon, CH3, CH3, CH3 and CH3. Okay. So agar exam mein aaye, if you get this type of question in exam, then what you should do, you should try it like this here first of all, and then try to make a structure. So all of these dots, they represent carbon atom, and the number of hydrogen atom you can infer by the number of bonds. So this is simple pentane. What will be the structure? This will be 2-methyl, na? Because we have 2-methyl butane. 2-methyl butane. You can see that it was pent, then it became bute. Okay, and then in this will be 2,2 dimethyl propane. Okay, so it became now prop. So we are changing the chain length, and that is why these are known as chain isomers. These are known as chain isomers. Okay, if you look at this particular chain, na, then you can say that, sir, here I have 1, 2, 3, and 4. So you have placed it at, okay, at the third dot. I can place it like this also here. But if you look closely, both of these structures are same only. Okay, so you have to make sure. So how to check if the both of these structures are same or not? Then you just write the IUPAC nomenclature for both of the things. If the nomenclature is same, that means the structure is also same. So in this case also, you can write the same name. Okay, so these two are the same things only. Tell me if you're done.
Done, sir.
Done. Okay, now let us look at hexane, है ना? Hexane के लिए देखिए. So it will start with simple CH3, CH2, 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 and CH3. I just want to write bonds 1, 2, 3, 4, 5, 6. Okay, so simple one. Then I will reduce the chain length 1, 2, 3, 4, 5. We have got, right? We have got 5 now. Then I will place one of the carbon atoms here. Okay, now again, if I see 2, 3, 4, and 5, if I move this carbon atom, if I move this bond to this carbon atom, now both of these structures are different. Yes or no? Tell me.
Yes, sir.
I know. Now let us try to move once more. So if you see this fourth structure and the second structure, they are same only. Yes or no?
Yes, sir.
Hai, they are same only. It is just that we have rotated it, nothing else. Hai, if you just try to rotate this molecule, then you will get the same second structure. गलत रोटेट कर दिया हमने. है ना, देखिए वही मिल गया. Only by rotation we have got the same structure. That means it is not different. It is just that we are looking from a different angle. So these are the structures for with how many carbon atoms in the parent chain we have. How many carbon? 5 carbon. Now we can reduce further more, right? We can reduce further more. We will write 1, 2, 3, and 4. And so 3 bonds. Here we have 3 bonds. What we can do, we can have both 5 and 6 carbon atom on the same carbon, or we can also have one carbon atom here and the other carbon atom here. Okay. Now, what else? We can reduce more. We can reduce more now. Yeah, I think we can reduce more. Okay. 1, 2. Now, in this case, if I have 2, then I will have to have here 2, 3. We have made 4 and 5. Achha. So let us see. Now I have 3 carbon atoms. Now I have 5 carbon atoms. But if I place one more carbon atom here like this, now, then again I'm making this 4th structure. That means we can only make 5. We can only make 5 structures. We cannot go after that. So you just write this down, and for all of them, you will write the hydrocarbon structure. Okay. All of you can write na CST करके फिर उसका नाम भी. Yes or no? Tell me.
Yes, sir.
Okay. So I hope you have written this. Then I will give you. I will write number of alkanes here. And here I will write the number of isomers. So CH4, it has 0. Then we have C2H6, 0. Then we have C3H8, 0. C4H10. It has how many? 2. C5H12, that is pentane. Pentane has how many? 3. And we just saw C6H14, it has 5. And after that we have C7H16, it has 9. Then what do we have? C8H18. C8H18 will have 18. C9H20, it has 35. C10H22, it has 75 isomers. Okay, all of them are chain isomers. So as you can see, there is not very good pattern here. Okay, you can't. Maybe you can remember this to make sure that you are making 5 different isomers for hexane, but there is no, what I can say, formula kind of thing. So write this down. Let me know if you're done. Done? Yes or no? हाँ guys, done? The nahi, not done.
Wait, sir.
Done, sir.
Wait,
Done, sir.
done. Okay. All right. Classification of carbon atoms in alkane. Carbon atoms in alkenes. Okay. So it is divided into 4 types. So right. If you have a carbon atom, carbon attached to only one carbon, it is known as 1 degree or primary carbon. Carbon attached to two carbons is known as 2 degree or secondary carbon. If you have a carbon attached to 3 carbons, it is known as 3 degree or tertiary carbon. If you have carbon attached to 4 carbons, it is known as 4 degree or quaternary carbon. Now, so if you have just CH3, so both of these carbon atoms are what? Let me, you write this down. I will give you questions. I think you can identify at least, enough. I don't need to explain much here, right? Done. I hope you have written at least till 2. You have to assign these things. Okay, in the following. Okay. So all of you, please turn the mic on. Zainab, Sarah, Matthew, and Aisha, specifically you guys, not Zainab, not Sarah. Zainab, Aisha, and Matthew, because you guys were not present in the organic chemistry lectures in my class. Samaira, आपको तो आता है?
Yeah, yes, sir.
है ना, हम लोगों ने तो किया हुआ है. Yes, Matthew, Zainab. Zainab, can you please turn the mic on? Aisha, are you there, right? Thank you. Now you tell me, this carbon atom, is attached to how many carbon atoms? This carbon atom is attached to how many? Okay, yes, one, na? One carbon atom. Hai so this will be what degree? 1 degree, 2 degree, 3 degree?
1 degree.
1 degree, all of you? Okay, very good. What about this carbon atom? So next one. This one?
1.
It is attached to how many carbon atoms? 2, na?
2. Yes.
2, na? Are?
Yes.
Matthew?
2.
Oh yes, yeah.
Oh yes, oh yes, oh yes. What about this carbon atom? देख के बताइए. How many? It is attached to
4.
how many carbon atoms?
4.
4, right? So 4 degree. Okay, what about this carbon atom here? This one that is above the 4 degree?
1.
1. Okay. What about this carbon atom?
1.
1 degree. Okay, what about this carbon atom? Yes, Zainab, correct. Yes, Matthew, Aisha.
2.
देख के बताइए. How many? It is attached to how many carbon atoms?
2, yeah, 2.
3.
3.
Wait, no, wait. Oh yeah, the other one is there, right? This side.
3 carbon atoms. What about this carbon?
1.
1 degree. This carbon atom is also
1.
1.
1 degree. Okay, it's also 1 degree. Okay. Now, next question. Okay. You guys are comfortable with this type of structures? Yes or no? First of all, tell me that. Aisha, Matthew, and Zainab.
Yes, sir.
What about you guys, Matthew and Zainab?
All right, so yeah, sure.
All right. Okay, fine. So A, B, C, D, and E. है ना? So and also this is F. These are the carbon atoms. You will have to tell me 1 degree, 2 degree, or 3 degree. So A, tell me guys. 1 degree, 2 degree, 3 degree.
2.
Okay, fine. Matthew, क्या हो गया?
Yes, sir.
B,
3.
3 degrees.
3 degrees. Okay. Then we have C. What
2.
about C?
2 degrees.
2 degrees. What about D?
2.
2. What about E?
1.
E.
Oh,
ये है ना
okay.
E.
E. Oh, yeah. 2.
2. What about F?
1.
1.
1 degree. Okay, fine. Chalo. That is it for today. है ना? That is it for today. And we'll talk about the boiling points and melting points. Zainab, you have not done states of matter with me, na? Yes, Zainab. Okay. Samaira, can you send her the states of matter notes?
Yes, sir.
Okay, the first lecture. Okay, first lecture. So in the next class, all of you will read the first lecture, read the notes of first lecture, rewatch the lecture or everything, because we have learned about the intermolecular forces of attraction, and that is something which determines the melting point and boiling point of a particular system. So you revise that and then come on the next class. Okay, that is on Thursday. Okay, one more thing. I think